Thank you, everybody, and welcome. Appreciate your time here today. I know you have busy schedules, so it's great that you could make it out here today. So, as Reed mentioned, my name is Mark Ramberg. I handle business development and media strategy at Amazon Web Services. I have been in the software industry for a long time, as Sean mentioned, or as Reed mentioned, 22 years professionally. But I actually got started writing code at a pretty early age, probably about 10 years earlier than that, when I was 12 years old. One of the first times that I started working with digital media was in the mid-'90s. I actually wrote a video editing and capture system, and I really got bitten by the bug for digital media at that point. Through the years, I spent time at various companies working on things like, in the late 90s, we digitized and put online the entire North American compact disc collection. In a few years ago, I was part of the project to put the Beijing and the Vancouver Olympics online, full HD streaming video. So I've kind of seen a progression of how the digital media industry around processing and distribution has progressed through the years. So that's what I want to talk to you a little bit about today. So I put this slide together, and I kind of cobbled together a few pieces of clip art here. But over the past 40 years, we've really seen a lot of change in media distribution, media processing. The ultimate goal being that you want to have content be distributed as easily as possible, as frictionlessly as possible, to the broadest possible audience so that they can consume that content where they want to, when they want to, how they want to. Now, there have been a number of hurdles throughout the years. Some of those have diminished. We're still getting through a few of them. But the main ones have been ubiquity of content consumption devices and consumers' access to content distribution endpoints. So it wasn't until the 70s, with the advent of the VCR, that we really started to give consumers the opportunity to do on-demand content consumption. So on-demand, really, like I said a minute ago, was the ability to watch things kind of where you wanted. You didn't have to go to the theater, for instance. When you wanted, so you didn't have to wait for the broadcaster to schedule it and wait up till prime time or whatever to watch it, and how you want to watch it. So on the devices that are maybe more convenient. So with the advent of the VCR and VHS specifically, it was a great product at the time, but there was still a problem in that even if you had a VCR, there was still a discontinuity in the content distribution pipeline. You had to go to the store to get the content. The device was pretty useless without its complementary product, the videotape cassette that contained the content. Now, there were some benefits. I mean, like I said, you could watch it when you wanted, kind of where you wanted. On the complexity side, from a distribution and production, replication perspective, it was still fairly straightforward and simple. There were only a couple of different VCR formats with VHS and Betamax. Replicating was basically chaining together a bunch of recorders to a master and doing the recording that way. So it's still fairly simple in terms of that. Now, I don't know, a little bit of a trivia question, and I do actually have a prize for anybody that can answer this question. I have a Kindle up here that I'll give away to the first person that can answer the question. So many of you may know that the Laserdisc also was coming on the scene right about the same time. It was actually introduced in North America only 2 years after VHS was introduced in Japan, so 1978. Now, Laserdisc had its own challenges and benefits and things, but the trivia question is, can anybody name the first major motion picture that was marketed in North America on Laserdisc? I haven't heard it yet. You got to remember the time frame here, 1978. Jaws. Who said Jaws? Good job. I'll get you the Kindle after I'm done. So fast forward about 20 years, really. So things were fairly status quo for about 20 years until the advent of the DVD. Now, the DVD had some great benefits to it. It was more compact, more durable. It was higher quality picture. Lots of benefits on that side. But like I said, kind of status quo still from distribution standpoint. While there were lots of video rental stores out there that kind of lowered the barrier to entry for people to get content with a VHS, those distribution endpoints still existed basically in the same way that they always had for the last 20 years. They did transition to renting DVDs, but it was still that discontinuity and distribution pipeline. You still had to drive to the store and get that content and bring it home and put it in the player and so you could watch it. It wasn't really until a few years later where we started to see that discontinuity get broken down a little bit. So companies like Netflix that started delivering DVDs right to your door. I mean, they made it a lot easier for you to be able to watch what you wanted, where you wanted, when you wanted. You really didn't even have to leave your house if you didn't want to. And then a few years later, with the cable operators offering on-demand services, where you could literally sit on your couch and with your remote, browse through a list of content that was available, decide to purchase it, have it applied to your monthly bill, so you didn't even have to have money in your pocket, and just sit back and watch it. So it was really kind of the first time when people could truly do kind of on-demand content consumption. So in today's world, many devices available. Phones, PCs, gaming devices, even in your car sometimes. Ubiquity of devices. And they're all highly connected. So content consumption friction from a consumer's point of view is fairly low. Now, if you look at the other side of that, on the production side, lots of technical requirements there. So with DVD, you started to see more technical requirements around, you needed authoring systems and encryption systems and interactive menus. With these devices, you have different formats all over the place, lots of interactivity, lots of different screen sizes, resolutions, codecs, DRMs, all these things add to the complexity of the problem. So even though this, like I said, is much lower friction for the consumer, to produce all this requires a lot more computational horsepower on the back end. The point being that over time, as you want to address more and more of the audience and make it easier and easier for them to consume the content, the production complexity has really skyrocketed. And that's for a number of factors, right? I mean, it's not only that there's all these different devices and formats and things like that, but there's more content available. And to be able to deal with that at scale really requires kind of a change in the game in the way that we deal with all these files. Now, this is a chart that I put together that it's sort of a typical digital media workflow for online content. This doesn't even include kind of physical production or managed network distribution. You can see there's a ton of discrete steps in this, right? I mean, you've got everything from digital asset management to encoding and DRM and monetization and analytics. All of these problems are getting more and more complex, and you multiply it by the number of devices and formats and files and everything. And it's really a crazy amount of processing required. So how do we deal with that? How do we tame that? The cloud provides scalability, provides elasticity. Your time to market is improved. All of these things can really help you with dealing with this massive complexity and scale that digital media processing and distribution has become. And even in these times of tight budgets, it can change the conversation from a capital expenditure conversation to an operating expense conversation. It makes it easier for you to respond to demand so that you can be more agile and more nimble, dealing with opportunities that maybe your competitors can't deal with as quickly. In the future, we also expect to see more efficiency and more efficient use of resources that are available. So for instance, as an example, if you get all of your content, like maybe the ProRes or the mezzanine files, up into cloud storage, it then becomes much easier for content processing services to come and act on those files. There's lots of efficiencies, so you don't have to ship the files around, which is typically very slow, sometimes very expensive. And then the more content, it becomes a network effect. The more content that you have up in cloud storage, the more of these processing service companies will want to come into the cloud and offer these services to be able to take advantage and be a part of that value chain. So the next few slides I want to talk to you about are some of the things that we've heard from many of you around challenges that you're facing, things that the cloud can help solve. So dealing with massive scale, having rapid file transfers, lowering your IT costs, having high reliability, and then security accreditation. So as a proof point, this is a case study that we did. Talks about scalability and how massive scale makes it easier to hit deadlines. So many of you have probably seen this slide before if you've come to any of our Amazon talks or looked at our case studies online. But basically, what was happening at the time, the PlayStation 3 was about to launch. Netflix wanted to make its library of content available on the PlayStation 3. Due to various reasons, schedules got pushed out, but not the launch date of the PlayStation 3. Netflix got to a point where they had less time than capacity to encode or transcode their library of 17,000 titles. It's almost 80 terabytes of data. Instead of looking at their physical capacity and saying, okay, we're bound by this, we have this much capacity and this much content, it's going to just multiply the two and we get the amount of time required, and that's longer than we have before the ship of the PlayStation 3. They came to Amazon. They started up 1,200 instances on our Elastic Compute Cloud and transcoded the entire library in a matter of days. What this really demonstrates, I think the key point here, is that it changes the story from a linear problem to a nonlinear problem. It lets you look at these things in terms of business decision. You can say, should I maybe save a little money and start up a number of GPU cluster instances, which are maybe a little more costly, and get it done really quickly? Or should I start up spot instances that I can bid on the reserved capacity and maybe run them at off-peak hours and save a bunch of money, even though it might take a little longer? But it changes the game, turns it into a business decision instead of a technology or a capacity decision. Another example here around scale. So Playfish, owned by Electronic Arts. A lot of their games are distributed through social networking. So they often have games that come out, they try and estimate demand, and the game will go viral before they know it, and what are they going to do? In the case of Restaurant City, they anticipated maybe 150,000 to 250,000 users initially. It scaled up to 4 million users over the span of 8 weeks. They were able to use Amazon Web Services, global infrastructure, and deal with that scale. Not have to worry about going and procuring more infrastructure. Letting them really focus on what's core to their business, where they can add more value. Another scale example. Personalized content. So Yelp, I'm sure many of you have used Yelp, maybe on your phone. They were initially running their own compute infrastructure, running an instance of Hadoop. And if anybody doesn't know what that is, it's an architecture that lets you do distributed processing of massive amounts of data. So it's good for things like correlating big data sets. A lot of times, if you go to a shopping site like Amazon.com, you'll see customers who bought this also bought this. It's those kind of correlations that Hadoop architectures are really good at. So Yelp was using that for recommendations as well. And what they found was, initially they had their own RAID storage arrays running their own instance of Hadoop. They moved all that over to Amazon Simple Storage Service, our S3 storage, and we're running about 200 Amazon Elastic MapReduce instances, which is Amazon's version of Hadoop we offer it as a service. They were able to get their hardware costs down. They said they saved over $50,000 initially by moving it all onto Amazon Web Services. And it really allowed their developers to focus on the things where they could add value. This slide talks about speed and how moving files, I touched on this a little bit earlier, but how moving files faster also makes it easier to hit deadlines. So Zencoder, one of our partners, sponsor of this event as well, one of the things that they do, they built their encoding system on top of Amazon Web Services. Now, in order for them to encode or transcode files, customers have to get those files into Zencoder's infrastructure or into their application. So download the files to Zencoder, then transcode them, and then you can use them and deal with them later. So you can either take those files from your own infrastructure, maybe on your hard drive under your desk or in your own data center or from wherever, and upload them to Zencoder. Or if you have those files already in our cloud storage on S3, you can transfer them directly from there as well. Now, because Zencoder is built on top of Amazon Web Services and S3 storage, and S3 storage is all fiber connected internally, the transfer times go way down. So the example here is a 1.5 gigabyte file being transferred, and you see the big bar there, being transferred from external storage, something external to Amazon Web Services, taking about 9 minutes. If you have those files already in Amazon S3, it took 7 seconds. So it's 80 times faster to transfer the files internally once you get that content into the cloud. I think that's an important point, and I'll talk about it a little bit later about ways to get content into the cloud. But we've heard from many of you that one of the big things that's kind of a barrier is, well, these files are huge. ProRes and mezzanine files are massive. How do I get those into the cloud very quickly and cost effectively? I'll touch on that again in a minute. So this example from another partner of ours, PBS. So PBS is using Amazon's CloudFront content distribution network to deliver their video content. So PBS was using a different CDN initially, and they were having some reliability issues. So they built a monitoring application that let them kind of test not only their own CDN that they were using previously, but other CDNs, including Amazon CloudFront. What they found was CloudFront was a much more reliable CDN, and so they are now delivering over 1 petabyte a month of video content through CloudFront. And the quote here, it says, "As with all the AWS services we leverage, using Amazon CloudFront is so simple and reliable that the team doesn't have to think about it. It just works, freeing us up to focus on building cool applications." I think you're starting to hear a theme here, right? So this is a slide that I wanted to talk about with costs. So traditional hardware infrastructure for running your own IT infrastructure, typically you buy it in discrete steps. So maybe when the annual budgets come around, you go and buy another pile of hardware, start putting it in the data center, but you do it on kind of discrete steps. That's not always the way that demand behaves. Your customers don't say, I wonder when his next hardware purchase is going to be. Let's go and try and watch their content then. It doesn't happen that way. What you end up with in this case, and you can kind of see the green arrow there, sometimes you have way more capacity than you need, and so it's kind of wasted opportunity cost. Sometimes you don't have enough capacity to meet the demand. That turns into bad user experience. With automated virtualization through something like Amazon Web Services Cloud, you can match the demand automatically with the capacity. A number of our customers talk about how much money they've saved, their IT costs, by moving their infrastructure over to our cloud. So a lot of people ask us about security. It's always a very hot topic. This is a list of some of our security accreditations. We're continually working on getting more security accreditations. Some of these are things for process and data integrity. Some are payment card. Some are government and healthcare. But you can see that we've got security accreditations for most of the major industries that have a lot of security requirements. But if you do need additional security services for any of your projects, we do offer a few other things. So one of them is Amazon's AWS Direct Connect feature. What this is the ability to directly fiber connect your infrastructure into our infrastructure. Now that can be, you can co-locate your infrastructure in our data centers, in our Equinix POPs, or you can have your own infrastructure at your own data center and have a fiber connection directly from there. Not only does this give you the ability to have more security because you're on a dedicated connection, you're not pushing the data across the public internet, it also gives you a lot faster connection. So you can have up to 10 gigabit connections directly into our data centers to push these big files. So that's what I was talking about earlier. Is we get a lot of questions about, well, I've got these huge files. How do I get them in there cheaply and quickly? This is one of the best ways to do it. Furthermore, we offer Amazon Virtual Private Cloud. So Virtual Private Cloud is basically the ability to partition off a section of the Amazon Web Services cloud and have it be private. It's your own virtual private network. It gives you, if you have requirements for higher levels of security doing that, this is a good solution. And then the third one that I have on the slide here is about dedicated instances. So if you have requirements that say, I really need to have my infrastructure running on a dedicated box, I don't need multi-tenant box, I can't have other customers using virtualized server hardware, this is a solution for that. On top of all these, we offer things like identity access management, where it's federated identity for things like integrating with your existing identity and access systems, federating that and using it within Amazon Web Services. Also offer things like multi-factor authentication, so if you want to have your users have a little key dongle that has a changing number as part of their password, all those kind of things exist. So from a security standpoint, we're fairly well covered. This is kind of the obligatory slide with a number of our customers. Amazon Web Services has hundreds of thousands of customers. This is just a few of them. You can see that there are lots of different industries, different regional locations, all kinds of different companies that are using Amazon Web Services for lots of different applications. Whoops, missed one. Going back. We do have a URL that we've set up. Very simple one here. But basically, if you go here, we've got white papers, we've got recorded webinars, lots of different information for you to learn about Amazon Web Services. There's information about how to get in touch with our enterprise teams if you want to talk to salespeople. And also, there's lots of people in the room here today that are going to be happy to talk to you about this. So with that, I will say thank you, and we will move on to the next presenter.